we will do quadratic patterns, linear patterns, and geometric patterns. So let us have a look at quadratic patterns. What is quadratic patterns? Pattern is quadratic if we have a common second difference. So quadratic patterns. So the quadratic, every quadratic pattern is in this form. Tn is equal to an squared plus bn plus c. That's a quadratic pattern. Now, how do I get the formulas? How do I solve for a, b, c? Okay, that's a question that you need to know. How to solve for a, b, c. So where did the formulas come from? That's what I'm going to show you. So if you put term 1, term 1 is a times 1 squared, which is a, b times 1, which is b, and c, that's term 1. What's term 2? Term 2 is putting 2 inside here. 2 squared is 4, 4a, plus 2b, plus c. And what's term 3? 3 squared is 9, 9a, plus 3b, plus c. Now, what we do is we make these blocks and we try to simplify this quadratic pattern. And we say, okay, where's the formulas then? If these are the pattern, where's the formula? So that's what I'm going to show you how to. Well, you don't need to memorize the proof for this. This is just a proof. So you know exactly where the formula is coming from. We're not guessing anything. I'm just making those, you know, the tree diagram, the blocks. So to put term 1 here, term 2 there, and term 3 there. We can put one more term here. I want to put term 4, right? So if you're looking at term 4, you can check this out. Term 4 will be 16a plus 4b plus c. Then after you do that, obviously over here, you're going to get the difference between those two terms. Then you'll get another difference here, and you will get another difference here. And guess what? After that, you will get a difference here, and you will find that the common differences are the same. The second difference in a quadratic pattern. Now, how will I solve this? I will put term 1, term 2, term 3. So this a plus b plus c. What goes here? 4a plus 2b plus c. That's term 1, term 2, term 3. 9a plus 3b plus c. By the way, this is a proof, all right? 16a plus 4b plus c. Now, how do I solve this? You see term 2 minus term 1. Okay, take the term forward term minus the term prior to that, before that. So 4a minus a is 3a, right? 2b minus b is plus b. C minus c is 0, so that's out. 9a minus 4a is 5a. 3b minus 2b is plus b. And you can see c and c is out. 16a minus 9 is 7a plus 4b plus b. And you can see that this here itself, the first differences also makes like a pattern. So this is difference 1, and let's see what's difference 2. Difference 2 is 5a minus 3a, which is 2a. And what is b minus b? 0. 7a minus 5a is also 2a, okay? So what we notice is that the second differences are the same. That's how you say the pattern is quadratic if the second differences are the same. A pattern is cubic if the third differences are the same. You can continue this for any number of polynomial functions, right? A pattern is linear if the first differences are the same, right? So second difference is a constant. So we can clearly notice that second differences are identical. This implies pattern is quadratic. That's how you prove that the pattern is quadratic. Right. Now, so how do we solve for ABC? Do we have a way to solve for ABC? Yes, of course, because this is now difference one formula, this is difference two formula, and this is term one, right? So that's where the formulas come from. So the three formulas that we have is 2a is equal to d2, 3a plus b is equal to d1, the first difference value, and then a plus b plus c is equal to term one. Okay, so the formulas didn't just come randomly. I mean, it was proved from the formula, right? So you had to go and basically prove them, right? So let me just take this out. So those are the three formulas that you need to know. Okay, and that's how you get, therefore, Tn is equal to an squared plus bn plus c. Okay, that's how you get the formulas. Now, let us have a look at some examples on quadratic patterns. Then we can do linear and, geometric. Let's have a look at some examples on quadratic patterns. We'll do about 4 examples. So, right, so see what he says. Consider the quadratic pattern. Consider the quadratic number pattern, 5, 12, 23, 38. So see if that pattern is quadratic. Let's check. We are adding. You see, in your exam, they usually tell you that what is the next two terms of the pattern. So try to see what we are doing. So we are adding 7. Then we are adding 11. Yes, 7, 11. Then we are adding 15. Yes. So determine a formula for the general term of the pattern. So that's what we're going to do. Find the formula for the general term. So 5, 12, 23, 38. We'll put that down. 5, 12, 23. You don't need all 4 terms. You just need 3 terms for quadratic, okay? So 12 minus 5 is 7. And then 23 minus 12 is 23 minus 12, 11. And then if you take the second difference, it is 4. So D1, D2. Mishka, can you hear me?
Yes, I can, sir.
Right, excellent. Now we're going to use the 3 formulas and solve. Right, so let's solve. What formulas? We need to use these 3 formulas here, okay? By the way, we're doing part A, guys, right? So let's see. Let's see how we're going to solve this using these 3 formulas. So we're saying 2a is equal to d2. what we just proved above now. You need to remember these formulas. So we're going to say 2a is equal to d2. What is the second difference? 4. So 2a is equal to 4. Therefore, a is equal to 2. Because a is 2, take this value of a and go put it there. So 3 times a will be 6. So you got 6 plus b is equal to us d1, 7. So b is now equals to 1. 2 plus 1 is 3. So a plus b is 3. Okay, so 3 plus c is equal to term 1, which is 5. Therefore, c is equal to 2. Okay, so now we got a, b, c. Now we can find the general formula, which is tn is equal to 2n squared plus b is 1, so plus n plus 2. Okay, now you can substitute a value and check if that actually works. Let's substitute 4 inside. 4 squared is 16. 16 plus times 2 is 32. And 32 plus 6 is 38. It works. Okay, so this was part A. Solving part B. Hence, calculate the value of term 15. What is term 15? Easy peasy, just direct substitution. Term 15 is 2 times 15 squared plus 15 plus 2, right? And please work this out in the calculator, someone, and give it to me. Kiara, work this out. What is 15 squared? 225. Multiplied by 2 is 450. And add 17. 467. Just check. Check if you get the answer of 467. Let's look at part C. Determine which term in the pattern has a value of 530. Which term in the pattern? So which term has a value of 530? We need to make Tn equals to 530. And what is Tn? 2n squared plus n plus 2 is equal to 530. Bring the 530 over. You get 2n squared plus n minus 528 is equal to 0, because you will say 2 minus 530. Now I need to solve this using the quadratic. Uh, use the quadratic on the calculator, okay? Yep, use the quadratic on the calculator. The calculator, yeah. Go to mode 5 and 3. So if you solve this, you got 2, 1, negative 528. Okay, I'm getting 16. So I will say n minus 16. And then 2n. 2n plus 33 is equal to 0. Remember, when we are doing number patterns, the values of n should always be natural numbers, okay? So remember, n has to be an element of natural numbers. N has to be natural numbers. In other words, you can't have fractions, you can't have negative numbers. It can only be 1, 2, 3, 4, 5, and so on. Right, so n is equal to 16, or n is equal to negative 33 over 2. We're going to say reject. So what's your final answer? Therefore, term 16 is 530. Okay, that's the answer. So determine which term in the pattern has a value of 530. 30. So term 16. You can write that in words. Term 16 has a value of 530. Now let's quickly go over the next few problems because I need to do. Right, so these are good revision. Right, they tell you the given pattern is quadratic, right? So they're telling you that the pattern is quadratic. So straight away start drawing your tree diagram. Determine the values of x and y. Value or values of x and y. So we have 1, x, 19, 37, and y. We want to solve for x and y, right? So x minus 1 is always term 2 minus term 1, right? 19 minus x. Then we got 37 minus 19. 37 minus 19. All right, I'm getting 18. And then I'm getting y minus 37. Right, this is only difference 1. Then what is difference 2? Difference 2 is 19 minus x minus. So it's 19 minus x minus x minus 1. You have to put it in brackets because we have two terms. Then this one is 18 minus 19 minus x. Right, and the last two. Right, so you can clearly see that these terms are bigger. So I'm just going to move this to the side. Right, and look at the last two. Right, that's going to be y minus 37 minus 18. Now let's simplify each one. If you simplify this one, you will get 19 minus x, which is 19 minus x plus 1. 19 plus 1 is 20 minus 2x. So that's the first one. This one is 18 minus 19 plus x. So this will become 18 minus 19 is minus 1 plus x. Why plus x? Because you remember you have to take the minus inside both the terms here, right? Don't make that mistake, please. And the last one is y minus 37 minus 18. So minus 37, right? You know what I'm subtracting? Minus 37 minus 18. I'm getting minus 55. So I've got y minus 55. Now, what we notice is that the second differences must be the same. These things has to be the same, right? That's why, because they told us that it's a quadratic pattern. So the second differences must be the same. So we can clearly see if we equate these two, the first two second differences, we can solve for x. If we bring the x over to the other side, we get minus 3x equals minus 1 minus 20, which is minus 21. So therefore, x is now equals to 7. We brought the negative 1, no, we brought the 20 over and the x over to the left-hand side because we had x's here. So we're getting x is equal to 7. Now, because x is 7, remember we can also equate these two. So we can say now minus 1 plus x equals y minus 55. So we can say, remember the value of x was 7. So minus 1 plus 6 equals y minus 55. So I can just take minus 55 over to the other side and add 55. And this is 5 plus 55. So y is now equals to 60. X is 7, y is 60. Right, so now if you try to put 7 and 60 inside here, you clearly see that it actually makes sense, right? So don't just take answers for granted. So we can have the pattern 1, 7, 19, 37, and what's y? 60. Double check your answer. How you double check here in this case? This is 6, 19 minus 7 is 12. That should give us 18. That should give us 24. Right, then 12 minus 6 is 6. 6 and 6. Yeah, so it works perfect. Okay, so we double checked our answer and we can see the value of x equals 7 and the value of y equals 60 gives us the perfect quadratic. And that can only be the two values. There are some difficult questions here. So the main thing is for a quadratic, try to draw this diagram. It will make life much more simple. You'll find that you'll find ease in calculating the stuff. Next question is on your screen. A quadratic number pattern has a constant second difference of 6. So what are they giving us? This is D2, which is 6. The first term is 4, so term 1. And the third term is 22, so term 3. Determine the general term of the sequence. How would I solve this problem here? I will draw my diagram, okay? Because they're only talking about the first 3 terms, no other terms, all right? That's why I'm drawing this diagram. Because the information given is very important. They told us that the second difference is given, so perfect. If the second difference is given, problem solved. So what they told us, term 1 is 4, term 3 is 22. So obviously I can't get any differences here. Right. Determine the general term of the sequence. How can we find the general term if we don't even have term 2, right? So we need to find term 2 first. That's our first problem. So let's call term 2 to be x, right? And remember what was your second difference? The second difference is already 6. So I will put this answer is equal to 6 because I'm putting x here. Then this here will turn out to be x minus 4. And this will become 22 minus x, right? And then what will your second difference here be? Let me make this block bigger. It's kind of like subtracting now. Right, so the second difference is 22 minus x minus x minus 4. That's a 4 there, right? Now, we need to solve this equation because they told us that the second difference is 6, right? So problem solved, second difference is 6. So solve for x here now. So you got 22 minus x minus x plus 4 is equal to 6. 22 plus 4, that is 26. Take 26 over to the other side. You'll get 6 minus 26, which is negative 20. And this is negative 2x. Therefore, x is equal to 10. Now we have x is equal to 10. And you remember the 3 formulas that we had. Just copy and paste from the other one, right? The 3 formulas that we had, we need to solve for Tn, all right? We need to find the general term. So there's it here. So what's the general term of the sequence? 2a is equal to d2, so we can write down 2a is equal to 6, a is equal to 3. 3 times 3 is 9, 9 plus b is equal to what is d1? d1 is x minus 4. But we just solve for x, all right? Which is 10, 10 minus 4. Uh, 10 minus 4 is 6, and if you take the 9 over, Remember, x is 10, okay? We solve for that. So 10 minus 4 is 6. Rather replace it with 6. Remember, the value of x was 10. 10 minus 4 is 6. So we have, take the 9 over 6 minus 9. So b is equal to negative 3. And then a plus b is 3 minus 3, which is 0. Right. You can clearly see a plus b is 0 plus c is equal to term 1. What is term 1? 4. So c is 4. Therefore, my Tn formula is 3n squared minus 3n plus 4. Right, guys? 3n squared minus 3n plus 4. Now, I want to substitute the value of 3 inside over here and double check my formula. So 3 times 3 squared, that's 27, minus 3 times 3, which is 9. 27 minus 9 is 18. 18 plus 4 is 22. So perfect, it works. Okay, so this is my answer, 3n squared minus 3n plus 4. Just quadratic patterns, okay? Now, because the pattern is quadratic, you can get many different types of questions that involves, critical thinking. Let's look at the next question. Given the quadratic pattern, negative 3, 2, 9, 18, determine the nth term, Tn, of the pattern. Easy peasy, right? Why is it easy? Because we got minus 3, 2, 9, 18. We can just draw the diagram and solve. So we got, let me do A on this side. So minus 3, 2, and 9, okay? So I'm just going to take those three numbers, minus 3, 2, and 9. I don't need all four. 2 minus minus 3, that is 5. 9 minus 2 is 7. And then take the second difference, 7 minus 5 is 2. And we only need these first few values. So that's difference 1, term 1, difference 1, difference 2. So I will use the three formulas that I have again over here. Right, and put it here and solve them. So as you can see, the formulas are 2a is equal to d2. So let's solve. 2a is equal to d2. So d2 is 2. So 2a is equal to 2. So a is now equals to 1. 3 times 1 is 3. 3 plus b is equal to difference 1. Difference 1 is 5. So b is equal to 2. Okay? Because 5 minus 3. And then a plus b is 2 plus 1, which is 3. 3 plus c is equal to what's term 1? Negative 3. Therefore, the value of c is taking the 3 over. C is equal to negative 6. So what's the answer? Therefore, Tn is now equals to n squared plus 2n minus 6. You can substitute 4 inside and check if you get 18. 4 squared is 16. 2 times 4 is 8. That's 24. 24 minus 6 is 18. So it works. Let's look at part B. Calculate the number of terms that will be less than 357 in this pattern. So Tn is less than 357. That's what we want to solve. But in this case, we can just solve for n, make it into an equation and solve, right? That'll be easier for you. So we can just say this implies, remember, we're still solving that. This is my original question. So this implies n squared plus 2n minus 6 is equal to 357. Now bring this over, n squared plus 2n minus minus 6 minus 357 is going to be minus 363 is equal to 0. Check if you can factor this out. Mode 5, 3, 1, 2, and negative 363. Okay, so I can't really factor this out. So I need to use a quadratic formula. So n is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. Right, so minus b will be minus 2 plus minus square root of b squared will be 2 squared, which is 4. Minus 4, a will be 1, and c will be minus 363 divided by 2 times 1 divided by 2. Now, uh, remember you already solved this, so no use typing the quadratic formula there. You already have the answer. If you press equals, you can press SD, you say you're getting an answer of n equals 18,0078. You need 2 decimal places, right? 18,08, or n is equal to negative 20,08. Now remember, this one will straight away be reject. Right. Remember what we are finding. We're finding the value of n such that it's going to be less than 357. So n should be equals to 18, right? Because if you try 19, it's going to be more than 357. We want an answer. How many terms are less than 357? So there are 18 terms, which is less than the number 357. So n is equal to 18. There you need to round up. Therefore, n is equal to 18. 18 terms in the pattern are less than 357. Okay, so that's what this part here means. There are 18 terms which is less than 357. You can try substituting 18 inside, and okay, let's try 19 here now. Mode. So we got 19 squared plus 2 times 19 minus 6. So see, I'm getting an answer of 393, which is way more than 357. Let's try 18 now. Right, so we're getting 354. So that's the closest one that it comes to. That's why we can't. Right, this is great. So let's continue part C now. The first difference between two consecutive terms in the pattern is 74. Determine which two terms are these, right? So what they're saying, the first difference between two consecutive terms in the pattern is 74. I need to explain this question to you. Let's retake this question. You need an explanation for this because this is a very famous question. The way it's structured, right? And it comes out everywhere. It has higher order thinking, right? So this was my pattern. I want to see what you want. The first difference, what are they talking about? The first difference between two consecutive terms in the pattern is 74. So what is the first difference between term 2 and term 1? It is 5. The second value of the first difference is 7. Then the value 18 minus 9 is 9. So what you want to find is there are two right, what you want to find is that there are two values in the quadratic pattern, a value there and a value there. And when I find the first difference between these two values, I get 74. You actually can't get 74. Should be 73, right? Right, should be 73. Now, determine which two terms are these. Which two terms? So which term of the quadratic pattern is this and this? So clearly, you need to go and find the formula for the first difference. Find the formula for the first difference. The formula over here is Tn is equal to, how are you going to find the formula for the first difference? Tn is equal to Bn plus C, all right? What is B? The common difference between these two. What's the common difference between 7 and 5? It is 2. And what is the value of C? The term before the first term. So before 5 would have been 3. So plus 3. Now substitute the different values in here. Example, just substitute 3 in here. So 2 times 3 is 3. 3 plus 3 is 9. You can see this formula works. So how did I get the 3? Just the term before 5, which is invisible. Right, so now this part, you need to equate this part equal to 73. Right, you need to equate that to 73. So 2n is equal to 73 minus 3 is 70. Right, so therefore n is equal to 35. So n is equal to 35 means it's this term over here. It is term 35. N equals 35 means it's a 35th difference. See, this is the first difference, second difference. 35th difference means quadratic pattern 35 and quadratic pattern 36. So the difference between the 36th and the 35th term in the quadratic pattern is 73. So Q36 minus in the quadratic pattern, the first difference between two consecutive terms in the pattern is 73. Determine which two terms are these. So it's the same pattern. The difference between term 36 and term 35 in the quadratic pattern. In the quadratic, not in this linear pattern now. When you say term 36 and term 35, it means for quadratic pattern. The difference between Q36, change it to Q instead of T. Quadratic pattern 36 and quadratic pattern 35 in the quadratic pattern is 73. If you call Qn to be an squared plus bn plus c, okay? So the difference between Q36 and Q35 in the quadratic pattern is 70. I hope you understood that, right? The first difference is 73. Right, so that was a nice question. Continuing building onto your knowledge, next two questions. Question 5 and question 6. Question 5 is very simple, easy peasy. It's just that the way the quadratic pattern is written is very important. Look at the way the quadratic pattern is written. Given the pattern Tn, which is equals to negative into n minus 50 all squared plus 20, right? What is the maximum value of this pattern? Anyone knows? Remember, this is written in the turning point form. It's written in the form a into x minus p all squared plus q. You can see the value of a is negative, and if this value of a is negative, The turning point here is already at 50 and 20. So there, the 20 is the maximum value. So straightforward 1 mark question this was. So the maximum value of this pattern is 20. Maximum value is 20, right? And it occurs at term 50. So maximum value of this pattern, max value is equal to 20. That's simple. Now, this is a question which is like higher order thinking, which is more like level 4. We are given the pattern Tn is equal to 2n squared minus 2n plus 5. Prove that each term of this pattern is an odd number. Okay, now how are you going to prove that this here is an odd number? First, if you try putting in some values, 2n squared minus 2n plus 5, and start from 1 to 5, try to generate a sequence, you'll find that each term is an odd number. Let's try to generate the sequence. You can use the table method. 7, 2 alpha x squared minus 2 alpha x plus 5. You're generating some values, okay? Start step 1, and so when you substitute 1, we get 5. When we substitute 2, we get 9. When we substitute 3, we're getting 17, 29, 45. Right, those are the values that I've got when I substituted 1, 2, 3, 4, 5, okay? And we can clearly see each one of them is an odd number. So prove that each term of this pattern is an odd number. Now, question is, what is an odd number? What's the form of the odd number? The form of the odd number is Tn, or let's call it Tk. The counter should be k here, right? So Tk is equal to 2k plus 1, or 2k minus 1. If you either have 2k plus 1 or 2k minus 1, then the sequence is odd, right? So if you double a number and add 1, or if you double a number and minus 1, you'll always get an odd number, okay? So now it means that we need to write this part in this form. So answer, solution, right? So what we have here is 2n squared minus 2n plus 5. So we write down 2n squared minus 2n plus 5. You see the 5. The 5, I can break up the 5 in terms of, always try to break up the 5 in terms of plus 1 or minus 1. So that's plus 1. 5 can be broken down into plus 1 plus 4. So I'm going to rewrite this. 2n squared minus 2n plus 4 plus 1, plus 4 plus 1. Now we can clearly see that from this entire first 3 terms, I can take out a 2. Right? And plus 1. Now you can clearly see that no matter what the value of n over here is, if you double, you'll get an even number. And if you add 1, you'll always get odd number. So now we can say this is 2k plus 1, where the value of k is equals to n squared minus n plus 2. Right, so remember n was a natural number. So k will also be, k can't be a natural number now. K depends. N is natural, then k will become an integer. Why? Why is k an integer value? Because of this n squared minus n plus 2 can be positive or negative. But in this case, it was only positive. Let's substitute n as 1. Yeah, so if n is an element of natural, k will also be a natural number in this case. But if you put integer, it's no big deal, right? It depends on what the first value is. So we got 2k plus 1, which is odd. This implies each term, this implies Tn is odd. That's it. Tn is odd. That's it. Right, so this was a little bit tricky. Now, if you're proving even, you just need to prove that is equal to 2k, not plus 1 and not minus 1. All right. Right, so that's great. Now, next part that we want to study is what is an arithmetic sequence, okay? What's an arithmetic sequence? So let's write this down. Actually, yeah, arithmetic sequence you kind of already know. Let's do both on this side. One is one arithmetic and one geometric. No. Let's just focus on arithmetic for now. Geometric we'll do when we are in that example. So arithmetic sequence. Right, so what you need to know in an arithmetic sequence is this. Remember, term 1 is equal to A. Term 2 is equal to A plus D. Just adding a difference. Example, just adding a common difference. If you add and subtract values to the first term, if you add and subtract values to the first term, then you get arithmetic. What is an arithmetic sequence? We have something called a common difference, right? Common difference. Common difference is equal to D. And first term is always A. First term, the value is A. So we started with the first term, we're adding a D. So term 2, we're going to add another D. So it's going to be A plus 2D. Term 3 is A plus term 4 now. Right. Term 4 is A plus 3D, and so on. So what's term N? A plus, see what's this? This was 4, that was 3. So if this is N, it's going to be minus 1. N minus 1D. Okay, and that's how you derive the formula. Okay, that's how you go and you derive the formula. Now note, from the, yes, if we want to find, you remember this question that we did, and we had a formula for this question with this first difference. See, we had 5, 7, 9, right? We had 5, 7, 9. So just giving an example, we got the numbers 5, 7, 9, 5, 7, 9. These are the sequence of numbers 5, 7, 9, 11, and so on. Now, if I want to find the general term of this, I'm just going to use this formula A plus N minus 1D, right? A is 5 plus N minus 1. What is D? Common difference is 7 minus 5, which is 2. You have to put it in brackets because sometimes you can get a negative. So 5 plus 2 times N is 2N minus 2. So we will get 2N, and 5 minus 2 is plus 3. So 2N plus 3. And that's how we use this formula. Okay. Now, what is more interesting is how to sum up this formula, right? So what is this? This is just an arithmetic sequence. Now, what's an arithmetic series? We do have a formula here now. What's an arithmetic series? Series is basically summing up terms, not a sequence, right? The difference between sequence and series is that you see these semicolons, these are separated by sequences. These are sequence of numbers. Series is changing this into plus, adding the sum. So if we try to do something like this, if I say find the sum of, find the sum of 5 plus 7 plus 9 plus 11 plus 13. If I want to find the sum of this, now remember, what if there are many numbers, okay? Because this is just 5 numbers, obviously you can find the sum. So what we do is, to solve this problem, we set up a forward sum and the backward sum, all right? So the answer, the solution for this, right? So it's solution. This is your question, all right? So what's the answer for this? So you're going to set up a sum formula, right? I call it the forward sum. Forward sum is just adding up all this. 5 plus 7 plus 9 plus 11 plus 13. Now you can clearly see there are 5 terms, right? But if you don't know the number of terms, you'll set the Tn formula equals to, you set the Tn formula over here equals to the last value to get the number of terms. Anyways, all right, so this is the forward sum. What is the backward sum? The backward sum is adding up all this backwards. So 13 plus 11 plus 9 plus 7 plus 5. And see what you get. You get like a nice pattern at the end, right? So remember, the forward sum and the backward sum is the same thing, right? This is still 5 terms. So s plus s is 2s, right? So let me take out forward and backward, right? So those are still s. You know, this is going in that direction, forward direction, and this is going in backward direction. S plus s is 2s, which is equals to 5 plus 13 is 18, 18 again, 18 again, 18, and 18. You see the same thing, you find a pattern. So 18, how many times is 18 repeated? 5 times, right? So now you're going to write 2s is equal to 5 times 18, correct? So this implies s is now equals to 5 times 18 divided by 2, which is 90 divided by 2, which is 45. So if you sum up all these values, you should get 45. So let's see. 5 plus 7 plus 9 plus 11 plus 13. Yes, I get 45. Okay. So you can see the sum over here. So this was the method. Right. So now we're going to apply this method to a general formula, which is Tn. Right. Now, I don't want you to get lost. Watch what we are doing. So what is the sum? Now, this is the formula that you need to learn. Proof. SN proof for arithmetic. I'm not going to write down the formula for arithmetic series. What's a series? Adding up all the numbers. So first I'm going to say the sum is equal to term 1 plus term 2 plus term 3, right up to term n minus 1 plus term n. Okay? You don't have to do a plus term n minus 1 and term. It's nice to do it, right? But I'm saying you don't have to. Now, let's see. What is your Tn formula? You're going to write down the Tn formula, which is a plus n minus 1d. Okay? So, S is equal to, I'm writing the forward sum, going in the forward direction, right? What is term 1? A. What's term 2? A plus d. What's term 3? A plus 2d plus dot dot dot. What's term n minus 1? A plus n minus 2d plus A plus what's term n minus 1d. Now you have to know this proof, right? They can ask you in any exam. It's an examinable proof. Now, this was the forward sum, right? Now I want to go and write down the backward sum. The backward sum will be adding up, see, Tn, what is Tn? A plus n minus 1d plus, what's Tn minus 1? I need to write this one next. A plus n minus 2d plus dot 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 plus, I'll just write that the last term, right? So a plus d, because I'm writing everything backwards, plus a. Now, very easy. Don't bother summing up those two. Just sum up these two. You know you're going to get the same value because I've already proved it to you with numerical numbers, okay? So don't waste your time adding up everything. You're just going to add up these two and add up these two to confirm. If you add up those two, then you have to end up opening the brackets and end up solving everything. Right, so we're just going to add up these two. So we're going to say s plus s is 2s, a plus a is 2a plus n minus 1d. And if you add up this one, you're going to get the same thing, right? So carry on, plus. And by the way, how many terms are there? There are n terms, right? If you add up those two, you'll get the same thing. So plus dot 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 plus a plus a is 2a plus n minus 1d. How many times? N times. Okay, n times. So we have a formula now. So this implies 2s is now equal to n times 2a plus n minus 1 times d. So what's s equals to? S is equal to n over 2 into 2a plus n minus 1 times d. Okay? So this is one formula. Or you can have another formula, which is s is equal to n over 2 into what is 2a? A plus a plus n minus 1 times d. And what is a plus a? Isn't this is Tn? Tn is regarded as the last term. So we use this formula here sometimes. If the first and the last term is given in an arithmetic, a plus l. So the example that I gave you before. So what can you use here? You can use this formula, which will always work, right? But if the first and the last term is given, use the second formula for summing up and arithmetic. Right, so you can use either one of the formulas. So the example that I gave you was find the sum of this, right? I want to find the value of this. So you have two options. You can use the easier one or you can use the, so I want to find the sum. So you're going to say S is equal to, now remember the first part is to get the number of terms here. So how many terms are here? We got 5 terms, 1, 2, 3, 4, 5. If you don't know the number of terms, you need to solve the Tn formula. So we got S is equal to, what's n? 5. So you're going to say 5 over 2 into 2a. 2a plus n minus 1d. What's 2a? 2 times 5. Plus, what's n minus 1? 5 minus 1. And what's a common difference? 7 minus 5, which is 2. Now, what I have here is 5 over 2 into 10. And 4 times 2 is 8. So I've got 18. 18 divided by 2 is 9. 9 times 5 is 45. So I'm getting the same answer. Or if I use the second formula, S is equal to n over 2, which is 5 over 2 into a plus l. What's a? 5. And what's l? What's the last term? 13. Right? 5 plus 13 is 18. 18 divided by 2 is 9. 9 times 5 is 45. Okay, so we get the same answer. So I hope you understood that. Obviously, this year, the TN formula you learned in like grade 8 and stuff, but not this formula. This formula we'll use in grade 12 because we need this formula to prove the arithmetic series. So what did we learn? That the sum of an arithmetic series, you got to learn this formula. This is an examinable proof. It's just 4 lines. 1, 2, 3, 4. Just write the first part and the last part, and you are done. And you have to write n times. Exactly that the way I have done it, you must do the proof in the same way. Right? So these 4 steps are very important in proving the formula. So after you have these 4 steps, then you obviously go to this one and this one. That's what you need to prove. You don't need to prove the second part, just this first part of the formula, right? So that's arithmetic series, the sum of an arithmetic series. Now let's look at some examples of arithmetic sequence. Obviously, we need to do examples so you can understand the work better. So it's starting from basics and then it will get a little bit challenging, right? So let's look at an arithmetic sequence. Consider the arithmetic sequence, which is 7, 13, 19, okay? So we have 7, 13, and 19. Determine the general term for this sequence. So the general term, we just use the previous formula that we have learned. So Tn is equal to a plus n minus 1d, right? So Tn is equal to, what is a? 7 plus n minus 1. What is d? 13 minus 7, which is 6, right? So 7 plus 6n minus 6. Try to write the n first, right? So 6n plus 1. Hence, calculate the value of the 40th term. So you're going to take term 40, which is 6 times 40 plus 1. That's 240 plus 1, 241. Right, so I hope you guys understood that. Right, that is straightforward problems. Look at question number 8. Which term in the arithmetic sequence is equal to 267? Which term in the arithmetic sequence is equal to 267? So which term means n? We are solving for n. So get the Tn formula first, which is a plus n minus 1d, and that must be equal to 267. Let's see, what is a? 3 plus n minus 1. What is d? D is 11 minus 3, which is 8. Common difference is 8. Right. Now, you can minus the 3 and divide it by 8. That's fine. Or you can just open up everything here, which is 3 plus 8n minus 8 is equal to 267. Continue here. 8n minus 5 is equal to 267. Just check on the calculator if it works out. 267 plus 5 divided by 8. Yeah, it does. So 8n is equal to 267 plus 5 is 272. Therefore, n is equal to 272 divided by 8. I worked it out. I've got 34. Right. I've used a calculator. Right, so this implies term 34 is equal to 267. Let's check. Remember, we got a Tn formula, which is here, right? This is my Tn formula. Let's substitute 34 here. So 8 times 34, 8 times 34 minus 5, 267. I'm getting it, right? So that's my answer. Right, so this is nice. Remember the problem before is that we didn't know the number of terms. What if you don't know the number of terms that are in the arithmetic sequence? So if you don't know the number of terms in the arithmetic sequence, you say the Tn formula must be equal to the last value. So then you will know what it is. So Tn again is equal to a plus n minus 1d is equal to negative 45. So a is 18 plus n minus 1. What is common difference? Common difference is 15 minus 18. 15 minus 18 is negative 3. So 18 minus 3n plus 3 is equal to negative 45. You can see minus 3n plus 3. We're opening the brackets up. You have to open up the negative 3 into the two terms here. Now, negative 3n plus 21 is equal to negative 45. Now you take negative 45, negative 21. So you'll get negative 66, I think. Yeah. So that's negative 3, and therefore n is equal to 22. So find the number of terms in the arithmetic sequence. There are 22 terms, all right? There are 22 terms. Right. So that's how you solve that problem. Now, remember, very important property of an arithmetic sequence is, remember when we were doing quadratic, we said in quadratic sequence, we have a common second difference. So in an arithmetic sequence, I wrote it down here. In an arithmetic sequence, we have common difference. We only have a common first difference. There is no second difference, right? So the first three terms of an arithmetic sequence are, right? Determine the value of x. How are you going to find the value of x? Remember common difference. The theory of common difference is that D is equal to D is equal to term 2 minus term 1. Term 2 minus term 1, which is equals to also term 3 minus term 2. Common difference. That's what common difference means. It means the differences are common. So if you subtract those two and those two, they must be equivalent. That's what we are doing. So if you take term 2 minus term 1, which is 4x minus 3 minus 2x plus 1, 4x minus 3 minus 2x plus 1, correct? And then 3x plus 4 minus 4x minus 3. And use this to solve for x, okay? So if you try to solve for this x here, you'll get 4x minus 3 minus 2x minus 1 equals 3x plus 4 minus 4x plus 3. Now, what we have here, we got 2x minus 4. Are now you there? You understanding? 3x minus 4x is minus x plus 7. Let's take this minus x over to the other side. You will get 3x and bring the minus 4 over to the other side. Everything looks right. 2x plus 1 here, 4x minus 3. If we bring the 4 to the other side, you will get 11. So x is equal to 11 over 3. No issues. It's just arithmetic, okay? So you can get fractions. But you must double check by substituting inside here. Right? So we know we have x to be 11 over 3. In other words, these things will end up being fractions now, your sequence of numbers. So this was part A. Part B, determine the first term and the constant difference of the sequence. Constant difference or the common difference. So term 1 is A, term 1. term 1 is equal to a, which is equals to 2x plus 1. Right? 2x plus 1 means it is 2 times, what's x? 11 over 3 plus 1. So 2 times 11 over 3 plus 1, please write it in fraction form. 2 times 11 over 3 plus 1. I'm getting 25 over 3, right? 25 over 3, and the common difference. What is the common difference? Remember, we found something here. Common difference is either minus x plus 7 or 2x minus 4. So let me just say 2x minus 4 or minus x plus 7. Let me just write minus x plus 7. And x is already uh, 11 over 3 plus 7. So 11 over 3. I'm getting 10 over 3, all right? Right, so common difference is 10 over 3, and the first term is 25 over 3. So problem solved. Write down the general term Tn. That's easy. Tn is equal to a plus n minus 1 d. That is 25 over 3 plus n minus 1. What is d? D is 10 over 3. So you just need to add up everything. This is 25 over 3 plus 10 over 3n minus 10 over 3. So I've got 10 over 3n, and then 25 minus 10 is 15 over 3, right? 15 over 3 is plus 5. Because I can do 25 over 3 on my calculator. I'm using my calculator here. Minus 10 over 3. I'm getting 5. 25 over 3 minus 10 over 3. Right, so I've got 5 plus 5. Right, so I hope you guys understood all that. Next question. Question 11. In an arithmetic sequence, fifth term is 17, 12th term is 45. Determine the first term A and the common difference. So now this is a nice question because, see, when we say the fifth term is 17, so let's just go through this quickly. So if I say Tn is equal to A plus n minus 1d, what is term 5? It's A plus 5 minus 1, 4d. What is term 21? Term 21 will be, just giving an example, term 21 will be A plus 21 minus 1, so 20d. What is term 9? A plus 8d, and so on. So just remember, it's always 1, n minus 1. That's the reason why we say, when you say term 5, don't go and write down the entire formula, right? But if you do write the formula, you will never make a mistake. So A, the answer for A, we say term 5 is 17. So remember, your Tn formula is A plus n minus 1d. So term 5, 17 means term 5 is equal to A plus 4d, which is 17. And term 12 is 45. So term 12 is A plus 11d is equal to 45. Determine the first term A and the common difference. So we got equation 1 and equation 2. There's equation 1 and there's equation 2. So we can just solve them by subtraction. So if you subtract both the equation, you can subtract either way, all right? So just say A minus A is dot. 4 minus 11 is negative 7, right? 17 minus 45 is negative 28, right? And cancel out the negatives on both sides, or minus 28 divided by minus 7, d is equal to 4. So if the value of d is 4, solve for A. D is 4, right? So 4 times 4 is 16. A will be 1. A is 17 minus 4D, modify equation 1, right? But now that is 17 minus 4 times 4. 17 minus 16 is 1. So therefore, A is equal to 1 and D is equal to 4. So the first term is 1 and the common difference is 4. Next question. B. Calculate the value of term 30. Now, term 30, you don't need to go and find the entire Tn formula because remember, you can use the same logic here. So what is term 30? Term 30 is A plus 29D. What is the value of A? 1. 29 times D, what is D? 4. So if you multiply everything out, 1 plus 29 times 4, I'm getting 117. All right, next one. How many terms in the sequence are less than 200? Again, C. So Tn must be less than 200. How many terms? So now you need to find the Tn formula, right? So Tn is equal to A plus n minus 1 times D. It must be less than, make it equal to 200. And then we're just going to round down, right? So what's A? A is 1. That's n minus 1. D was 4 equals to 200. And so now I'm not gonna, you want to solve for n, right? So let's see Tn. So 1 plus 4n minus 4 is equal to 200. 4n minus 3 is equal to 200. So you got 4n is equal to 203. So n is equal to, what's 203 divided by 4? 203 divided by 4. 50,75. Right now, 50,75, it means that at 50,75, you're going to have 200. So you have to have n as equals to, let's see, what was your Tn formula? This one here, right? 4n minus 3. So I'm saying n must be equals to just 50. 50 terms. So there are 50 terms which is less than 200. So let's check. What if I substitute 51? If you substitute 51, you're going to go beyond 200, okay? So yes, 4 times 51 minus 3. 4 times 51 minus 3. You're going to go beyond 200. You're going to get 201. We don't want that. We want less than 200 only. So 50 terms are less than 200. There are 50 terms which are less than 200. The value of 200. That's what it means. Continuing here. All right, I'm not going to do geometric sequence. That will be our next lesson. So those questions are geometric sequence, not going to do it. We stopped at question number 11. Now we're going to do question number 12, right? So we did an arithmetic series, all right? The formula for arithmetic series. Right, so let's have a look at arithmetic series. So question number 12. Arithmetic series. Now, what is a series? The sum of numbers, okay? So how come this is not a sum? Well, there's your first term, right? There's your second term. There's your third term. Now, what are you doing from each term? So there's your second term, which is minus 1. So you want to calculate the sum, right? You want to calculate the sum of all these numbers. So first of all, we don't know how many terms there are. So we need to start by doing that. So we're going to start by saying, okay, Tn is equal to A plus n minus 1 D, and that must be equal to 37. Why are we doing this? We want to find the number of terms. So the value of A is negative 3, as we can clearly see. But what's the common difference? You can do common difference like this: minus 1 minus minus 3, which is minus 1 minus minus 3 minus 1 plus 3, which is 2. And you can clearly see we are adding 2 each time. -1, how you jump from -1 to 1? You're adding 2. That's what your common difference is. You're adding 2. If you're adding and subtracting, then that is your common difference. Or you can say -1 minus -3, which is 2, right? So which is equals to 37. Now we have -3 plus 2n minus 2 is equal to 37. Now 2n minus 5 is equal to 37. Take the -5 over. Remember, this is your Tn formula now, right? We will take the -5 over, we will get 42. So therefore, n is equal to 21. So now we know that there are 21 terms, right? And now we can solve the formula because remember, we got the first term and the last term. Sn is equal to n over 2 into a plus l, because we have the first term and the last term, and now we have the number of terms. So we're going to say S21 is equal to, did I write this Sn formula before? I think you might have made a mistake in writing. When I was teaching the Sn formula, we should have written S5 here. This is sum to 5 terms, okay? S5, S5, yeah. But that was just showing. Now we're actually doing the problem by substitution, okay? So S21 means 21 over 2. What's A? The first term is -3, and the last term is 37. Right, so now you can just put this into the calculator and get the answer, which is 21 over 2 into -3 plus 37, okay? And we have an answer which is 357. So the sum of all these terms is 357. Are we good, guys? Yeah, so that was question number 12. And question number 13. Given the arithmetic sequence 2, 5, 8, we can see A equals 2, and D, we are adding 3 each time, or 5 minus 2 is 3, 8 minus 5 is also 3. So D is equal to 3, okay? Those are the important stuff that you need from a series. Now, find the smallest value of n such that the sum is greater than 400. Easy. So use your normal Sn formula. We want the smallest value of n such that n is greater than 400. Greater than, okay? So we're going to say Sn is equal to n over 2 into, now we don't have first and last term, so we have to use this formula, 2a plus n minus 1d, right? And which must be greater than 400. We are solving for n here, right? So make this equation, make it into an equation and then substitute one higher value, lower value, and see which one it is. But I think in this case, you need to round up. Let's see. N over 2 remains n over 2 into 2a. 2 times a is 2 times 2 plus n minus 1. What is d? D is 3 is equals to 400. Okay. Now, see what I'm going to do is, because I have a 2 here, I'm going to multiply both sides of the equation by, okay, let's see. N over 2, let's see how this equation turns out to be. 4 plus 3n minus 1. You can see that. 3n minus, no, 3n minus 3, not minus 1. Minus 3 is equal to 400. Yeah, so I think we will end up with a problem because this is 3n plus 1, right? And this is n over 2 equals to 400. If you open up this entire equation, you're going to get 3 over 2n squared, or better, multiply the entire equation by 2 first. If you multiply the entire equation by 2 on this side, you're going to get 800. And that's n into 3n plus 1. Now make a quadratic and solve. N times 3n is 3n squared plus n minus 800 is equal to 0. I don't think this will factor out, but let's just put it into the calculator and see this. Mod 5, 3, 3, 1, negative 800. Yep, again, quadratic formula. So n is equal to minus b, which is minus 1, plus minus the square root of, what's b squared? 1 squared minus 4, ac, which is 3, and negative 800 divided by 2 times 3. Right, so I have two answers. N is equal to, I'm not going to type this entire thing, quadratic formula there. I'm using the equation solver. It's already giving me the answer, which is 16,16, or a negative 16,49 will turn to 50. Right, now you can clearly see you're going to reject this one. Now this one you have to round up because it's greater than inequality. So n is equal to 17. Now, how do we know n equals 17 works? Let's see what was the simplified form. It was equals to 400. There's your SN formula here. Your simplified SN is right here. Okay, this is your SN formula. Now substitute 17 inside here, right? Substitute 17 inside here and see what you're getting. 17 mod 1. We want the smallest value of n such that Sn is greater than 400. That the sum of all the values is greater than 400. So we're going to go 17 over 2 into what it was, 3n. So 3 times 17, 3 times 17 plus 1. That's your Sn formula, equals 400. I'm checking if the answer is greater than 400, right? Yes, this is 442. But now what if I change that into 16? 392. So you can clearly see 16 does not work. So in this case, you need to round up. You must know when to round up and when to round down. You only round down when it's less than, and when it's greater than, round up. The answer needs to be round up. Round up when it's greater than. So smallest value, minimum is equal to 17. Minimum smallest n value. Right, so minimum, or now let's look at the second one. Sn is less than 150. We want the largest value. So B, Sn is less than 150, but this implies we already have the Sn formula, okay? Sn formula was n over 2 into 3n plus 1, which is equals to 150. Right, that's what we have here. N over 2 into 3n plus 1. Now, multiply both sides by 2, you will get 300 onto the other side. And now open everything up, you will get 3n squared plus n minus 300 is equal to 0. Now, solving for n, I don't know if this will factor out. Let's check. So mod 5, 3, 3, 1, negative 300. Again, it doesn't factor out, so quadratic formula again. Right, not necessarily you always have to use a quadratic formula. In these scenarios, you have to, right? So minus b, let me just write down the quadratic formula, minus b plus minus square root of b squared minus 4ac divided by 2a. So what you are substituting are these values here now. Minus b is 1, plus minus the square root of 1 squared minus 4. A is 3 and C is negative 300. Divided by 2 times A. What's A? 3. Remember the values of A, B, C here. A is 3, B is 1, and C is negative 300. And that's what we are substituting. And so the value of N is equal to, or N is equal to. So N is now equals to 9,83, or the value of N is now equal to negative 10,17. Right, so reject here. Values of N can't be negative. And this one, we're going to round down. So N must be equals to 9. Round down. Right, so N must be 9. Now let's double check our answer and see if we actually getting less than 150 when N is 9. So this is the largest value, okay? Largest value or the maximum value. Now let's check satisfying this condition such that Sn is less than 150. So we got 9 over 2 into 3n plus 1, right? So 3 times 9. Why 3n plus 1? Because that's what it was. We need to test this formula, but the answer needs to be less than 150, okay? That's what we want. This is my Sn formula, and the answer must be less than 150, not equals to 150. It's equal to 150 when it is 9,83. So that's why I'm checking now. 9 over 2 into 3 times 9 plus 1. See what I'm getting? 126, which is less than 150. But now if you rounded up, if you went and put 10, let's see what you're going to get now. If you put 10, you will get 155. You will get more than 150, which we don't want. So now I know that my answer is 100% correct, which is the largest value is N equals 9. Okay? I hope you guys understood everything. All right, so